Hello boys and girls, this is Mr. Kizik, and in this video today we're going to be looking at difference of squares, sum of cubes, difference of cubes, and just other ways that we can factor these different polynomials. So if you recall from a couple lessons ago, GCF, remember, is just finding what's the greatest common factor here. So for number one, the greatest common factor between 12 and 10 is 2, and I can also factor on a squared. What's left over? 6a plus 5 after I divide by everything. Same thing for number 2. The greatest common factor is 7 m squared n squared. And when I divide both terms here, I get 2m to the 6th, n to the 3rd, minus, and then 1. Okay. Also recall when we talked about the difference of squares. Remember, the difference of squares is in this form here: a squared plus a squared minus b squared. Remember our perfect squares, that list we did: 1, 4, 9, 16, 25, 36, 49, so on and so forth. And remember, the rule is a plus b, a minus b. Okay. Going through this rather quickly is just because this should be a review. So if I look at number 3 here, again, the first thing you always want to check for is there a GCF? There's not. And both these terms are squares, or perfect squares. 9's a perfect square, x squared is a perfect square. Anytime I have an even exponent, it's a perfect square. So I take the square root of both terms here and put it in the rule. The square root of 9x squared is 3x. So that goes here with a plus, 3x with a minus. And then the square root of 49y squared is 7y. If I look at number 5, first thing again, you want to make sure or factor out GCF. There is a GCF here. It is 7 mn. So what does that mean? What I have left over is m to the 6th minus 4n squared. So now if I take the square root of both terms here, because it's still a difference of squares, we know it is because m to the 6th is an even exponent, so that's a perfect square. And 4n to the squared, all that's a perfect square. So my final answer would be 7mn. Now the square root of m to the 6th is just divided by 2, so m cubed plus m cubed minus, and then to take the square root of the other term, it's going to be 2n for both parts. All right, so we've looked at stuff like that before. Well, now let's talk about sum of cubes and difference of cubes. So sum of cubes, well, that it has to deal with perfect cubes. So what are perfect cubes? Well, it's the number multiplied 3 times. So 1's a perfect cube. And then I do 2 times 2 times 2, 8's a perfect cube. 3 times 3 times 3, 27. 4 times 4 times 4, 64 is a perfect cube. 5 times 5 times 5, 125. And we'll just do one more. 6 times 6 times 6 is 216, and so on and so forth. So the rule for the sum of cubes, when it's in this form here, a cubed plus b cubed. The rule is this. It's a plus b, that quantity, times the other quantity, a squared minus ab plus b squared. Okay. So how do I deal with the sum of cubes? Like, how do I factor it out here? Well, if I look at number 7 is the basic kind of cube problem that you can get here. X cubed is a perfect cube because anytime I have an exponent that's a multiple of 3, that's a perfect cube. 27 is a perfect cube because if I look at my list here, it's right there. So this right here, we need to basically take the cube root of both terms here. In other words, we can write this as a is x, because that's x cubed, plus, and at what number did I have to multiply by 3 times here to get 27? It was 3. So that means here, a is x, b is 3. So all I'm just going to do is just plug in each of those values in for the letters above. So a is x, b is 3, so it's going to be x plus 3. That quantity times the quantity a squared, or x squared, minus a times b, or x times 3, which is 3x, plus b squared. We said b was 3, so 3 squared is 9. And that's it. You know you're done here because even though this x squared minus 3x plus 9, there are not two numbers that multiply at 9 and add to negative 3. Let's look at another one. Number 8. M cubed plus 216n cubed. We know both terms are perfect cubes, so this fits in the sum of cubes category because this can be written as, well, what's the cube root of m cubed? That's m. So this is m to the third power plus 216, the cube root of that is 6, and then n cubed, well, if I divide that exponent by 3, I get just n, like that. So a is m, b is 6n. So what you want to do is just, again, place it into the correct spots of your rule. So a is m, b is 6n, so it's m plus 6n times the quantity of a squared, so m squared, minus a times b, so m times 6n, minus 6mn, plus b squared. 6n squared would be 36n squared. Let's look at number 9. So just like before, we want to find, for any of these, anytime we're trying to factor, is there a greatest common factor? And there is a greatest common factor here. The greatest common factor is 4. I can factor out 4 from each part. So when I do that, I get 4. Now divide each term by 4. 125a cubed plus 1. Here again, we've got the sum of cubes because 125a cubed can be written as, well, what's the cube root of 125? It's 5, and the cube root of a cubed is a. So a cubed plus, and then 1 cubed. So that means a is 5a, and b is 1. So let's replace those values into our little rule. So a plus b, so 5a plus 1, times a squared, so 5a squared is going to give me 25a squared, minus a times b, so 5a times 1 is 5a, plus b squared, or 1 squared, which is 1. Let's look at the last example here for the sum of cubes. So again, we want to see, is there a greatest common factor that can go both evenly into 375 and 224? And I'm just checking with my calculator here. No, not 12. Okay, so it's not 2, is it 3? Yeah, 3. So 3, now let's look at the variables. I can also factor out c, and I can factor out d. What's left over is 8c cubed plus 125 d cubed. So I can rewrite this parentheses here. Well, what's the cube root of 8? 2. And the cube root of c cubed is just c. Plus, the cube root of 125 is 5, and the cube root of d cubed is d. So that means a is 2c, b is 5d. Put it into our rule, a plus b, so 2c plus 5d times a squared, so 2c squared, which would be 4c squared, minus a times b, so 2c times 5d, which gives me 10cd, plus, and then b squared, 5d squared, which would be 25d squared. And that, ladies and gentlemen, is how you factor sum of cubes. So I'm just going to stop the video here, and then in the next video, we're going to look at difference of cubes. Remember, if you have any questions, please feel free to contact me and message me. This is Mr. Kiesik.